Hello again, everybody. This is problem 4 from Quiz 3, our Spring 23 Math 302 class at Cal State Fullerton. And in this problem, we're back to some set theory questions. So we're given 3 sets. The first one, R, is kind of odd, right? You have a set containing the number 1, the number 2, as well as the set that contains the numbers 3, 4, and 5. Then we have S, which is just the set containing 1, 2, 3, 4, and 5. And if you're not careful, you might think R and S are actually the same set. But it's important to note that these are not the same set. In fact, R and S do share 1 and 2, but 3, 4, and 5 are not elements of R. Only the set containing 3, 4, and 5 is an element of R. And then the third set is T. And this looks very much like S, only it's like there's a typo or something, right? There's 2 sets of braces. So T is actually the set containing 1, 2, 3, 4, 5. So you can see in T, the element, right, and I use the word the, right, very specifically, is a single element. It is a set itself. And it happens to contain stuff. Okay, but in fact, we could write this as the set containing S. And then you can see T is actually just a single element. All right, so we want to do some computations. So let's see, the first one, we just want to know how many elements, right? So remember, these bars mean the cardinality. How many elements are in each of these 3 sets, and we'll add them together. So for R, we end up with 1 element, 2 element, and then you have a set as the third element. It does not matter that the set happens to contain other elements. R can't see that. It just knows it contains this set. So R has 3 elements. S, now this is very straightforward. We have 1, 2, 3, 4, 5 elements. Nothing tricky here. And then finally, T, well, we know T only contains 1 element. Actually, it's the set S. So T has cardinality 1. And so in total, the sum of these 3 cardinalities, 3 plus 5 plus 1 is 9. Okay, now what about the union of R and S? So the union, recall, is all of the elements that could show up in R or in S. So let's see. Well, 1 shows up, actually shows up in both, but we don't write it twice because sets can't see multiple elements. 2 shows up. Then you have this weird set, 3, 4, 5. It's not the elements 3, 4, and 5. It's the set containing the elements 3, 4, and 5. And that's everything from R. And then in S, you have 3, 4, and 5. Okay, what about R union T? Well, we get everything in R. We could just copy that again. 1, 2, the set containing 3, 4, 5. And then we get everything from T, but there's just one thing, right? The set S, or if we write it out in full, the set containing 1, 2, 3, 4, and 5. Okay, now what about the intersection of S and T? So the intersection is all the things that are in both S and in T. Well, S has 5 elements, 1, 2, 3, 4, and 5. T has only 1 element, and it's the set S, right? Happens to be the set containing 1, 2, 3, 4, and 5. Well, S is not in the set S, right? S only has 1, 2, 3, 4, and 5. And 1, 2, 3, 4, and 5 are not in T, because T only has the 1 element, S. So there is nothing that is in both sets. So this is actually the empty set. All right, finally, P of T, the power set of T, or the set of all subsets of T. All right, so I'm going to use just this simple notation here. T being the set containing S, what are all of the subsets? Well, you always have the empty set as a subset. Now, what if it's non-empty? Well, then it has to contain an element, and there's only 1 element for T to contain, namely S. So I could have the set containing S, which is actually equal to T itself. And that's it. That's all I can possibly do, right? When you have 1 element in your set, the power set will only have 2 elements in it. Okay, so there we go. All right, so if you're getting these wrong, it's likely, again, because you're missing on this idea that if you have a set within a set, the superset, the big set, right, R in this case, for example, cannot see the elements within that element set, right? It won't see the 3, 4, and 5. Once you get that, these become probably very, very simple for you. All right, we'll see you all next time.